This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git Push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome to Ship It, the podcast all about what happens after you Git push. I am your host, Justin Garrison, and with me as always is Autumn Nash. How's it going, Autumn?
I had real food. I'm so excited.
Good job. Good job
There's
eating
food
that.
and caffeine. I'm like bouncing in my seat.
You know, we got a lot of replies in Slack. Did you see them about people listening to our voices at faster speeds?
Okay. So somebody said they listened to us at was it double the speed? Do we sound like chipmunks, y'all? Because the way that we sound regularly, like when I'm caffeinated and Justin has candy and Dr. Pepper, do we sound like chipmunks at double speed? Like, I can't listen to my own voice, so I'm not going to do the experiment to figure this out, but we need to know. Do we sound like chipmunks?
Most of the podcast apps do a really good job of not raising the pitch. It's just they lower it, but also I know some of them will remove white spaces. So if I stop talking right now and they have that setting turned on, it would just collapse that white space there.
I love that you just did the Justin excited voice, excited face when you stop talking.
It was a demo, so it was cool. But anyway, today on the show, we have Steven from Scanner. Steven's going to talk to us about the architecture of basically collecting logs at scale, which is cool because I used to run Logstash and Elasticsearch, and there's a lot of things out there that kind of do a similar-ish thing, but he has a very specific focus on security teams using it for what does it look like logging for a security team. So it was fun talk about what the architecture is and how that impacts the cost for both him and the customers, as well as what the general use cases are. So it was a lot of fun.
I think logs are so important. And I also think when people are planning startups or just planning products in general, it's really important to think about not only what you want to build, but how people will use your product. Because I think sometimes we think that people will only use our product in ways that we design them, and that's never how it goes. You know what I mean?
And I've lived through plenty of places where it's Elasticsearch was there for just collecting query logs, and then it became the source of metrics, right? And then you're like, oh, I got to query this all the time and run these indexes. So then now it becomes metrics, and then those metrics get displayed on a dashboard, and that dashboard is refreshed every second.
Exactly.
And that had direct impact on the architecture of our Elasticsearch clusters. And it's just maybe that wasn't the best place to, and not only we shouldn't be looking for metrics out of the logs, we could just export metrics that are just easier to collect and scale and all that stuff. But there's so much information in logs that it's hard to ignore them. And I absolutely wish that logs could just go away and we didn't need them anymore, and we could debug things on the fly, because log storage is expensive and sending logs is a lot of bandwidth and all this stuff, but they exist for a reason.
Also, at a certain point, you may say, hey, this is really interesting. Let's start capturing this, let's start querying for this. So I think things change and they grow and they evolve. So you have to take into account how those things will evolve eventually, and how they may be used. But I also think that the one thing that I learned from my solutions architect days always comes up is using the right database and data store for the right things. A lot of people will just be like, well, I have experience in this database, so I'm going to use it for logs, or I'm going to use it for this. But all of those databases have specific use cases in which they do better for, so you can't just say oh, well, also I think people always get NoSQL wrong. Just because NoSQL is flexible, it doesn't mean that you can just put things in and take it out however you want to, or you're never going to have good performance, so
absolutely agree that picking the wrong tool or the wrong architecture is going to directly impact performance and cost and scalability and all that stuff. But also I feel at least from my neck of the woods of NoSQL databases seem, or schemaless, was just we just don't want to make a decision now. right? Like, let me just like punt that decision to someone in the future. Future me will have to live with whatever bad decisions we make today by not making the decision. And in a lot of ways, like schemaless was flexible enough to be like, well, you could just update your app to make that better in the future. And it's like, well, you could still get better performance and scalability by making a decision up front.
It really is wonderful because it allows you to say, hey, we may need to add a column or add this later, or, look at this differently later. But you do know certain things. If you have an app and it's a login and you're going to take a username and a password, those things are important. You know what ID or name or however you're going to look it up. So planning and having good planning in the beginning is really important to your performance, but you still get the flexibility of, hey, I may want to play around with this or that or add this feature and have that flexibility, but it's flexible. It's not no schema. It's not no thought has to be put into it. And us lying and telling people that is why we end up with bad performance. And then, then we're always like, well, this database, like, I'm just going to throw things out and just say, well, people will say Snowflake's worse than this. But what is Snowflake's like use case? That is for analytics and for learning more about data. You know what I mean? And for dumping a bunch of data in and being able to find it. So it's like, I think we have to be careful of saying that things have bad performance or bad value when we're using it for the wrong use case,
Yeah. And knowing that those use cases change over time, right? Because like the decision I made up front of like my logging system only needs these 3 fields, and then all of a sudden your logging system is something else, and some other use case comes up where they need more information. Like you have to be able to adapt those things for sure.
Exactly. Or if your data set or your what you're storing is smaller, a lot of times people will be like, I can use S3 with Athena on it and it'll be fine. And then eventually your app gets so big that you have to find some sort of a NoSQL database or just any kind of relational to NoSQL at some point for applications. So I think a lot of times people will have more experience with certain databases, so they want to use it for everything. And some databases are almost made for that, right? Like Mongo is a really good, easy, like beginner, or maybe you don't have a ton of experience and you're going to build your first app, or an app that you don't want to be super intensive for like database like learnings and stuff, and they're made for that. They have so many like learnings and stuff and like Mongo University for databases, and then AWS has a version of that same database, you know what I mean, and they're partners. So it's like there's some databases who are made for, hey, you want to put something in something flexible, you want to not have a ton of experience. And then there's some databases where we know you're going to need that skill level to run it. Like Cassandra requires a certain skill level to scale it and to maintain that. So it's like sometimes in production you have to make that decision and be like, we have people that can do this, so we're going to pick this one or whatever. Like there's not always best practices, but you do have to really think about what product you're choosing.
All right, so let's jump into the interview with Steven, and we will be back afterwards to talk about some of the recent Azure outages because they've been having a month in July. So we'll be back soon.
What's up, friends? I'm here with a new friend of mine, the creator of Bitwarden, Kyle Spearin. Bitwarden is well known as the open source password manager out there to secure your digital life. And now they have a secrets manager to keep devs safe, to keep secrets safe, secure keys, tokens, and machine credentials with easy scalable access for humans and machines. So Kyle, why is now the best time for you to launch a secrets manager at Bitwarden?
We've been doing password management for a long time. And if you sit back and ask yourself, well, what's the difference between a password and a secret? A password is a secret, right? A lot of it comes down to kind of the integration point of what we offer. Secrets Manager is kind of another platform of doing the same thing that you do in password management. There's a lot of similarities, and that's why it made sense for us to move from just doing password management into secrets management as well. We also have a very strong user base that is very centric to kind of our open source message and our developers themselves. So it very much aligns with who our core user base is that we tailor to. So secrets management was a natural evolution for us to go into. Password management hygiene of users is really bad, and that's the problem we're solving with Password Manager. I don't know about you, but if I look back at my career and how I evolve, and especially developing new projects and other things, secrets management is also pretty bad hygiene, or especially in the earlier days for a lot of people. And you can kind of get into the rut of doing bad things, and you can permeate a lot of those kind of bad practices in a lot of ways to other aspects of your business that it's important to stay ahead of. We think that it matters a whole lot to developers to use a familiar platform that they know and love and can trust to kind of solve their other problems, that clean up the hygiene of what they do on the internet and how they build applications and how they manage secrets across their applications.
Okay, get streamlined secrets management for developers at bitwarden.com/secrets. Get end-to-end encrypted Bitwarden Secrets Manager, clean up your hygiene for your secrets, secure your infrastructure, your machine secrets, and your developer secrets. Start a free 7-day Bitwarden Secrets Manager trial today at bitwarden.com/secrets. That's bitwarden.com/secrets.
Hello and welcome to the show, Stephen. Thanks for joining us today. We usually like to start off with just what software are you responsible for?
So I'm the CTO of our startup. So I pretty much, our startup is a 7-person company. So I pretty much do everything because there isn't that much.
That's an engineering team right there. That's
yeah. So I guess is this like what is our stack more interesting, or
so let's start what is the startup? What is it doing? And
so we're Scanner. We are I guess the tagline is that we're like a petabyte scale log search and storage company. So imagine something like Splunk or like Datadog or like CrowdStrike Falcon. I don't know if it'll still be timely when this comes out, where basically if you have application logs or security relevant like access logs, you dump them in S3 and you might have terabytes or petabytes of them. And we run a bunch of distributed systems that index them. And then we have some extremely, I guess I'd call them extremely opinionated cloud native architecture query engine that goes through and searches it really fast, so you can ask it about all the things that are in that data. Yeah, that's the high level.
So let's describe that infrastructure a little bit more, because there's plenty of log searching engines, right? Like I could do Logstash from back in the day, or plenty of open search. There's things that exist that we could pull off the shelf. What makes Scanner different, and how does that architecture impact it?
There's kind of a couple of things. So basically, we're cloud native, right? A lot of these older generation stuff, like Splunk, like Datadog, like stuff based around Logstash, et cetera. A lot of that tends to be, it's very important to these companies because of a function of the times that they have like good on-prem solutions, and they kind of have these applications that are designed to be run on physical computers and so on, right? So if you're running a Splunk cluster, you have like a maybe not a physical computer, but even on the cloud option, it's like a VPC somewhere. And that's like a node, and that handles all of the capacities of the system, which includes concerns like storage, concerns like compute. And one of the big things is that for the most part, right, your usage of those resources are not uniform over time, and they are not uniform in any given instant. For instance, you need storage all of the time, but you pretty much don't query most of the time, right? So if you kind of think about like what the average query use case looks like, you spend like 5 minutes typing stuff into the search box every day, and then the other 23 hours and 55 minutes you're not, right? So when you have physical computers that have some constant resource constraints and some very spiky resource constraints, you have a lot of like weird utilization issues, and this leads to a lot of basically cost. So in our system, we basically each of the pieces of that system, each of those concerns are farmed out to the cloud service that is specialized towards handling that, right? So all of the index files go in object storage like in S3. We run, like ECS clusters or whatever. Well, not whatever, that's what we do. I actually know that for the actual indexing. And then we run basically serverless compute for doing the query. And each of those things are chosen specifically because that particular operation has a particular set of properties in terms of the volume, the spikiness and variance, the availability requirements, and so on, that are very, very different. And I can kind of talk about any of those in detail. I don't want to get lost too much in the specifics, but this is and I think we're kind of seeing a world now where in the current generation of these log search platforms, people are more and more, you'll see the term separating compute from storage more and more in like people's marketing material, right? Because I think we are realizing now that even very, very large companies like Fortune 50 companies are moving all of their stuff to the cloud, that you can now, in fact, build things with the assumption that pretty much even the biggest companies have enough cloud stuff for you to work with. Whereas I think even like 5 years ago, you couldn't. Like if you wanted to work with a big financial institution, you had to have some literal on-prem distribution where you like gave them a computer. So I think it's like there's a sea change that's kind of enabled this to be possible kind of in like the business landscape and just in terms of people moving from on-prem to cloud generally.
How do you feel like your company can still bring value even though people seem to be, we won't say like one size fits all, but a lot of people seem to be moving away from the cloud because they feel that the cloud has gotten so expensive. So how does your startup stay relevant with this kind of a narrative? Doesn't mean that it's necessarily true for everyone. I think cloud is valuable, on-prem is valuable, but right now we seem to be in like this cycle of narratives and that is one of the current ones, right? So
yeah. Well, this isn't exactly a direct answer to your question, but our product is extremely cheap compared to pretty much any other product in the space. I feel like throwing out numbers feels really salesy, but the normal like actual charge we see tends to be like a literal order of magnitude lower than stuff like Splunk Cloud, which is like a comparable cloud service in terms of functionality. We see people with cost as a concern, but at least for the kinds of companies that we talk to, none of them really feel that it's realistic for them to move completely off the cloud. And these tend to be like, because our main use case is actually security, our product is marketed as a SIEM, which is like a security information event management system. And the smallest company that has like a security team of 5 people is like $1 billion company. So that's like the smallest company that we work with. And for those companies, I think once they have infrastructure, the inertia and the size of what you have just means that you can't move off the cloud so much as you're just trying to cut cloud costs. So I think what we build fits really nicely into that narrative because it's like, oh, it's like a cloud service that kind of works alongside and takes advantage of everything available to you in that environment, but it also doesn't break the bank like pretty much every other logging service does.
But how does that fit with like the actual native services, right? Because
Mhm.
you're not going to beat the price of S3, right? Athena with S3 is going to be cheaper than anything else out there, and I don't know about the cost for CloudWatch at scale, but like CloudWatch is a similar.
S3 isn't a comparable product because you can't search S3. You can use something like Athena.
Right, Athena is the
really terrible.
I love Athena. I used to use Athena at
You're the first person I've ever heard say that.
I have not used it for a while, but when I was using it for production workloads, I thought it was fantastic.
Yeah. So I will say that Athena works. It's very easy to set up. You don't have to set it up. You just dump your files in there and it runs. And that's kind of similar to the story that we have, right? I'll say one of the common demos we do, like when we do like cold outreach and they're like, hey, you want to see the product? And they're like, sure. And we show them this demo where we have some search over a demo Athena data set, it's a couple 100 terabytes. And we start at the beginning. And then we run the search on our platform and it finishes in like 5 seconds. And then we go back to Athena and it's still running. And then we go like do the call. We actually stopped doing this because it costs a lot of money. But we were doing this for a while where it'll just run the entire sales call, like a 30 to 40 minute sales call. We'll come back and be like, hey, Athena's still going. We stopped doing this because it costs us like $100 per call, it turns out, when you do this. But that's how I'd say that our product is differentiated from or better than just using Athena, which is that Athena doesn't do indexing and Athena has like a limit to how fast it scans things. And there are some things that Athena does really quickly if you partition in the correct way and know exactly like which keys to hit and so on. But that isn't all queries. And we find that a lot of people are just like, oh, like I have this request ID and I like need to find what happened with this request ID and it happened like 6 days ago, right? Or like maybe it happened 5 days ago. I don't know which day it happened. And in that case, Athena is not very good because Athena just does a full data set scan every time. And they don't have indexing. And I think their particular, what they have in terms of compute, in terms of the query engine, kind of requires that they do the scan because of the like other properties of the system, I guess.
how do you differentiate yourself between the fact that you can, a lot of databases and database like engineering is how you, for one, like tune your database and your schema and the different ways like that you can bring in a database architect and get better throughput and just kind of like deal with your data better. So like, how do you?
I also don't have a direct answer to that question because pretty much everyone we talk to does not like using things like Snowflake for various reasons. I think if you're doing a lot of these kinds of application logging things where you're just like, oh, I have a new service, I want to just dump it into logs. It's a pain in the ass to ETL that into some form where it is columnar that you can put it into like a schema full system.
Yeah, well, I mean, every database has a schema, but I mean, Snowflake is definitely more if like you want to do analytics on your workload or something, that would be something that would be really expensive for a log use case. What is like so most of like is what your like use case, is it just for logging or
Yeah, we're basically fully focused on the like kind of free-form text search with aggregations use case. So our product is not schema full. So you can dump arbitrary text files or JSON files into it, and it is aware of the concept of columns, but there's no like, you don't have to pre-specify these are the columns we want to index. We index pretty much everything you dump in, and the columns end up just kind of being like metadata information on that data where, I mean, I don't want to say it's like NoSQL because it's not a database in the traditional sense, but it is NoSQL. There's like no tables, no schema. And kind of the goal is just to make it as easy as possible to get your data in there and have it be usable, and then to have the right tools so that you can still kind of treat it as if it were columnar, which is like an interesting technical problem, I think. And I think a lot of our resources have been spent on like, how do we make this system fast, and how do we make these particular aggregation operations feel good? And like, what do you do if someone does aggregations on columns in weird ways, where that column has exactly one value in the entire database, and it's like somewhere over here in this corner, everything else is null for it. And I don't think we solve it perfectly, but I do kind of think that for the most part, there are notable advantages of using something like what we do over using something that requires a schema. And I think it might be true that if you had like a really, 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 really big cluster of whatever database system is your preference, and you like sharded it, and you had like a guy or like two guys full-time running it, that you could get comparable or better performance, but it would cost you a lot more, both in terms of having two guys running it, but also just in terms of you would need a lot of beef to handle that much MySQL or that much Postgres or that much Snowflake even. And I brought up Snowflake because Snowflake is one of the direct, when we sell to a lot of these security teams, Snowflake is the preferred data store. And a lot of companies, I don't know how familiar you guys are, but like Panther Labs, for instance, is like one of the larger SIM tools, and their entire product is built on top of Snowflake. So they basically they just give you access to like querying on Snowflake, which is very powerful, right? But then also it costs the same as Snowflake. So that ends up being a blocker for lots of people.
we have to be careful though? Like I think NoSQL is flexible schema, not necessarily no schema, because that gets you into a lot of trouble. And I think a lot of the issue is that logs, you want to be able to dump them and you want to be able to query them, but you don't want to spend a lot on it because you know that you are going to just collect massive amounts of data, right?
Yeah.
But that's kind of like picking the right database, because you don't want to pick something that is made for analytics and for querying like a column database like a Cassandra or a Snowflake, because that's not really, I mean, you can put logs in those, but like Snowflake, you know that you're going to like pay for that. You know what I mean? And
I completely agree, but people do that in practice.
oh yeah, totally. But I think that like that's where database architects come in with like using the right database. But I do get where you're coming from. I just don't want to like tell people that NoSQL databases are schemaless, which just starts, we will get like database people fighting. But I get it.
They have no predefined schema. You don't have to predefine what columns you want beforehand. I think is maybe a better way for me to describe our product, at least.
Yeah, they're more flexible.
I completely agree with the better product thing, or better best database thing. I think part of what we've tried to do is design a product that is the quote unquote best database for the particular use case that we have. And a lot of it's like weird trade-offs. There are a lot of kinds of queries we can't do under our current architecture. Like we don't support multiple tables. We don't support joins. And it's because those things are nice to have, but not high priority for when you are like a security analyst, or you are like even like a guy doing DevOps stuff, where mostly what you're looking for is a particular needle in your haystack, or you're like looking to see if, like have any of these IPs try to hit my system, right? Like that sort of thing. And it's useful to see aggregations, but it's less useful to have these like really big, complicated joins that you might see in like more traditional data warehouse software. So I think that's kind of also would.
Your use case seems like it would be valuable for maybe smaller teams that can't bring in someone to help them work on their schemas or architect their data, like, to like be able to retrieve and put it in the right way. So maybe it would be better for like a smaller team that just wants logs and doesn't want to, like, maybe it doesn't have like database specialties or like that kind of a like knowledge, it would make it more straightforward to be able to just dump in the logs and get what you need.
I think that's empirically been untrue. I think we mostly work actually with larger companies.
Oh, okay.
I think the problem with the database guy is that headcount is really expensive.
Yeah, it is.
Like the database guy costs you 6 figures. And I think
Or
in today's, or girl, but in today's economy, given kind of the direction we see with lots of these teams, and also just a lot of companies we work with are, you might say like new wave IPO companies where they're not necessarily profitable, where I think right now cost is just very, very important. And so being able to not need a DBA and not run your own cluster of extremely large, beefy hardware has been just financially valuable, where like if you have a team of 4 or 5 analysts, it's nice to just be able to have that team of 4 and 5 analysts and not need 4 and 5 analysts and a DBA. I think is kind of, I guess, my counter to that.
When we were first talking about this episode, we weren't really talking about cost, but it goes along the lines of, you were mentioning how you scale up and down quickly with your queries as a differentiator for keeping your costs low, right? Like that's we have something come in. Can you describe how that works?
Yeah, I mean, so basically the boring version is that we just use serverless. And I think there's a lot of interesting details with this, but basically
you're gonna have to define serverless there, because there's a lot of things that.
Yeah, so we use, for instance, we use Lambda on AWS. So we use basically scalable compute, and Lambda has some really nice properties. So Lambda can go from 0 to like tens of thousands of compute CPUs pretty much instantly, and then it can go back down pretty much instantly. And this flexibility is great if you're willing to pay the cost, which is it costs a lot. Like it costs twice as much as normal compute.
It is the most expensive compute option on AWS.
Yeah, basically. But if you kind of think about like the properties of how querying works, like how do you query your data set, right? You query your data set for 5 minutes a day. And so if you're paying for 10 minutes of compute to query your data set for 5 minutes a day, that's still better than paying for 24 hours of compute to not query it for 24 hours a day. So in the long run, people need 10,000 CPUs for not very long each day. And so it ends up kind of being, in terms of the trade-offs, the right choice. I think there's also lots of interesting things that fall out of our decision to use Lambdas. I don't know how deep we want to get into like the specifics of the stack, but
if I understand it, like I go in, I type a query, like I'm looking for something in the logs, and then you just fire off a bunch of Lambda functions that are going to look at each section of the logs or each index.
Yeah, well, we have an index, and then yeah,
you can limit not raw looking at the logs, right? Like not every Lambda is downloading something from S3 and then looking at it, but at some point there's going to be an index of like, oh yeah, this section has it, so now go get the raw data and go find the relevant information, right?
Yeah, I think a lot of what's like tricky or difficult about systems like this is that like it turns out doing really simple things is really hard when you have 10,000 little guys doing it at the same time. And I think a lot of the trade-offs that we make that are real technical concerns end up just being like, oh yeah, it turns out that if you do this on one computer, it's super easy, and if you do this on 10,000, it gets weird. And happy to kind of jump into that. I don't know what the direction I want to take is.
Well, yeah, I mean, at some point, everyone outgrows Lambda mostly because of the costs, right? So like if people are only querying things 5 minutes a day, it's fine. But once you have enough customers that every 5 minutes someone's querying something, it would just be faster to run an EC2 instance. Or faster and cheaper.
Not just that, but it's also the length of the longer query, because sometimes a query will start off not that long and you're only doing it for 5 minutes, and then you get more and more customers and all of a sudden it's running over at that time. That makes Lambda like efficient.
Yeah, pretty much all the customers we work with require their own environment. None of them, because a lot of it is kind of like, oh, it's like sensitive security data, right? It's like log data, it's like our access logs or our firewall logs or whatever. People don't really want to do multi-tenant for what we do. So a lot of the appeal of how we present our product is like, you just get your own account. It's just your stuff in here. There's no one else's stuff in here. There's like no chance of like, oh, like someone messed up the database settings and now you can look at the whole database, because there's only one database and it's just for you. And the thing you say about the EC2 stuff is true. I think that one of the ways you can think about how something like Lambda works, right, is that you are literally benefiting from implicit multi-tenancy, because AWS is running that on the same, like,
S3 is still multi-tenant, even if you're not.
Yeah, but it's like a good way to kind of, because everyone trusts AWS to do their multi-tenancy well, whereas they might not trust random startup number 3 to do their multi-tenancy well. like that part's definitely true, right? At some point, we kind of are just like going to be pegging the physical hardware underneath to 100% all day because of volume. But when it comes to particular, like we can't actually share EC2 between multiple customers because they all want their own stuff. And the average size...
I mean, you could run an instance, right? Like that's the...
We can, but the average team size is like 10 people, and that doesn't scale up that high. Like even if you look at very, very large companies, like some of the companies we talk to are Fortune 50 companies, and they have multiple different security teams, but those individual teams are still
siloed.
Yeah, and they're like, like they have like a dozen or 24 analysts, and that's the entire team. So the query use case, and this kind of happens to be the case for a lot of kind of like more security analysis side stuff, where the read volume isn't high, but it is very like if you look for the data, you want it to show up instantly, but you're not doing that most of the time, most of the day. We did have a company that hired some consultants to do their querying, and they would like copy paste these queries where they would look for one IP at a time, and they would just do this all day. They had like a script that this is like once every minute for like an hour every day. And then we kind of saw this and we're like, hey, you guys can just use an OR. So then they did that. But I think for the most part, you don't see super, super high query load. Like, I mean, I guess in terms of costs, like the Lambda costs that we have are usually one of the smaller, like if you look at the AWS like breakdown of costs, it's usually one of the smaller things that we get charged for.
Well, sure. I mean, if you're storing logs, log storage is always one of the, where you're storing it is always the highest kind of thing. It's just like a bunch of stuff that you don't know if you need or not. And reducing the amount of things you store is the easiest way to drive down that cost. Especially even if it was like, I have a petabyte of S3 storage and I have an EC2 instance, right? Like the EC2 instance is going to be lost in the noise of like, it doesn't actually matter. But what I find interesting here is you're doing S3 for the storage, which is still, again, the highest cost of the system probably, and Lambda, which is the highest cost compute you could buy, that you run single tenant for each customer. And then in that case, you're not going to get overlap. You're not going to get reuse. You're just going to be paying the extra overhead of Lambda usage for each customer, whether they're using the system or not, right? Like if they're not using the system, great for you. There's no extra cost there.
Well, that's what I mean. There is no overhead of Lambda usage for us, right? Like the overhead is a constant factor.
Unless it's being used, right?
Yeah, the overhead is a constant factor on being used. So what we actually do is we just don't run it unless you ask for it, right? Like the system fast starts all the compute the instant you hit enter on a query, and then it fast spins that down. And so the overhead is, if we use DC2 during that time, we would pay half as much, but that time is not a lot of time.
Right.
During the rest of the time, we pay zero instead.
Right. And the overhead I was talking about was actually cognitive overhead for using Lambda, right? Because Lambda is harder to do those 10,000 workers than to say, oh, this one process is going to do a thing. Like you could architect the system more simple by saying it's a load balancer in front of EC2, ASG, and S3 in the back end. And it's just like, oh, it could always run and there's no overhead for it. But I still come back to this. Why wouldn't I as a customer use OpenSearch? Right, as a hosted service that is a little more query friendly than Athena and has a lot more, I guess, community around it. Like I don't have to learn a specific. There is a specific syntax to query it, but there's enough information on the internet that it's not a very specific. Like OpenSearch is just a generic search engine for these logs.
Yeah, so I think it kind of comes down to if you are doing that, you're still paying costs. So I don't know if OpenSearch is as popular with the clients we talk to, but a lot of people use things like the ELK stack, like with Elastic, and a lot of that. It sounds really nice when you see that because it's like, oh, like if I just run my own Elastic server or whatever, it's free, right? But it's not actually free because you still actually pay for the compute and you still actually pay for the 3 or 4 guys who now need to maintain it and
or girls,
like. Yeah, or girls. Sorry, I'm using guys in a gender neutral sense,
but it's not. So I'm just pointing out, guys is not gender neutral. So
sure. Sorry, I kind of lost my train of thought there.
But it takes time and it costs money. Like the most expensive thing in your infrastructure is the people that run it.
Correct.
Right. And in some cases we outsource that people that run it to another company to mostly hide that cost. And we say, hey, I'm going to pay them more money than I would pay my own people, because I don't want to have to think about it, right? Like the cognitive load of like, I don't have to manage a team is great, because it's just like, oh, that's one of the huge benefits of the cloud in general, is just like, I'm going to pay more money, but I have less cognitive load and my company is actually smaller and we can do different things. We can focus on different areas than managing those people that would run the thing for us.
Sure. I'm not sure what to say here other than that all in, our product costs about 10 times less than running Elastic yourself. It is both cheaper and less cognitive overhead. I don't want to like sound like a marketing track or whatever, but I think one of the upsides of having chosen our architecture is that we chose it to cost less, right? We specifically chose it because there are qualitative differences in how cloud services run that allow you to build a system that is cheaper and better suited to the problem.
But that cost less isn't static, right? If I query the system 100 times a day or 100% of the time a day, it's like more expensive, right? Like these architecture decisions drive direct impact on the cost, right?
I mean, yeah, you could, but nobody does.
Nobody does yet, right? And like this is just like, if more people start using it and there's more information there to be gathered, at some point there's a tipping point when you outgrow Lambda just as a cost model.
I think one important thing here is that the usage pattern of a product like ours is not the same as that of a consumer product. Like people don't, if you're a 10-person team of analysts, you don't use the product more and more of your day. Your analyst team doesn't grow at the same rate as your company and so on, right? Like I said, we work with some very large companies that are worth billions of dollars or more. And we don't notice that those guys have a higher propensity. I mean, they spend more on querying because they have more data, but they don't necessarily have a linearly higher propensity to query because they are a larger company.
The size of the company doesn't matter. The value of the information does. Right. And as soon as there's valuable information, I want to query it more, and I could automate those queries. Right. It's like, as soon as I say, oh, you know what, I can trigger something based on that data, I'm going to query it every 5 minutes.
Yeah. Especially because it like stops you from having to think about it. And then if something goes wrong, you can then go look at those intervals and compare them. So
right. And then I'm going to store that information that I got from queries that I'm going to run every 5 minutes because it's there and it's available for me. I'm going to go store that in a time series database.
Well, I don't know. I don't think I'm here to defend the market use case of our product, which exists, but
I'm just trying to point out that like the market use case is never the actual usage, right? The intended reason that product exists, customers will find a way to make it valuable to them. If they say this thing is valuable, they will use it however they want, and that architecture that you design has impact on what they are able to do and your costs directly.
I completely agree with you. I think you're completely right. I mean, in terms of like, what if someone just queries nonstop all day, 24/7? We've never seen anything even close to that. But if they did, yeah, like we charge for query. At some point, we have like a threshold, a very generous threshold of free query capacity, and then when you get past that, you pay us like, I don't know the exact number because it's part of it's like contract negotiated, but it's like $2 a terabyte, right? Which is Athena costs $5, so it is less than Athena, which also has the same property, right?
But there's always that tipping point of like elk is cheaper.
That's true.
Like, hey, if I want to query this all the time, guess what? Like paying the person and running the elk stack is cheaper. Like there's never like a flat line of like.
You're right. It just doesn't happen. And I'm pretty confident in saying that.
How will you keep keeping that cheaper when the cloud providers are all providing a similar service that they have the means to eventually make it cheaper? You know what I mean? Depending on how big the customer it is.
Yeah. Well, they already provide that service, right? They already provide Athena. There's already like Azure Sentinel. These products already exist and they aren't cheaper. And I mean, someday they might be. But I think that is kind of the nature of
tech in general.
Building a product. Like products get better. Our product will get better. Their product will get better. Maybe in 10 years, we'll be forced off by like market monopoly pressure when AWS decides to release exactly our product, but better like they always do. I think that's just the threat that pretty much every cloud provider has, which is that, like, why doesn't the cloud provider just use their hardware to do your thing, but without your margins? I think that's very reasonable.
I don't know. With current trends, they're all going to deprecate every service. So I don't think you have
to
worry about that. All the services are going away. They're not adding any more right now. So
that's true. But I think in practice, we have been cheaper than the native cloud provider provided services and faster, blah, blah, blah. I don't know. I feel weird talking up these properties of the products. I feel like I'm doing a sales thing and I'm not trying to do a sales thing, but
well, but like every property has a trade-off, right? Like it's not like you chose properties for a very specific use case for a very specific reason, and those things absolutely are faster and cheaper in that context, and then they are not faster and cheaper in another context, and that is the thing that is always the like, you got to find the right person that has the context, and that's great. And like if you find that person, like we want this, we have this many people overhead that do the thing, like then absolutely this architecture is the thing you would want to build, and here you go, we built it for you as a product, you can just go buy it.
yeah, I completely agree with you. I think that we actually did a lot of like before we built, we talked to a lot of people, and we kind of, I mean, like the standard product development type stuff, right, where you like kind of go through what the use case is and how people use their product. And we talked to a lot of people, top of funnel, and I think it's pretty much never the case. Like our trade-offs work for most concrete implementations of security team processes and DevOps team processes that we've encountered. I think it is certainly possible that someone could run a script that queried nonstop 24/7. We don't really see that often with something like a Splunk. I mean, I guess there's something like you have like online detection rules.
And I just want to say you don't see it yet, right? Like, because it's always it's going to come.
If it does come, I think there are definitely, if you're automating a query, for instance, there's actually things. So there's this notion of a thing called like an automated detection rule for like XDR type stuff. And basically the idea is that you have some query. So the way that Splunk or like Datadog or those guys implement it is that you have some query, right? And it runs every 5 minutes. And it's a query like, did this thing happen? Like, did someone change admin permissions on my AWS roles? Or did someone change whatever? Did we get ingress from like weird IP addresses that we know to be compromised? Stuff like that. And when those find something, they like send off an alert. So it's like the whole workflow. And those queries are queries that you run pretty much every 5 minutes, every minute, whatever. But they are also the same query that runs every 5 minutes, right? So you can like, for that particular use case, we actually have a bunch of these. We have like incremental caches where you can kind of, if you're careful about how you select your aggregations and how you select their mathematical properties, you can actually build like a cool little roll-up tree where you're effectively only running that query over your entire data set once ever. You just do it incrementally as it comes in. Stuff like dashboards, same thing, right? Like you can kind of build this cool incremental cache of everything, and then you just ask the cache for this range and it tells you, and there's no query cost involved. So I think for stuff that isn't ad hoc querying, like stuff that isn't freeform exploratory querying, which I think in that model that you're talking about is probably most of that like very high volume automated, like people doing this query every 2 minutes on a script type thing, that basically doesn't cost us anything at all, right? Because of that choice of caching. And it is true that like all of it is trade-offs. I think we have made really strong, very specific opinionated trade-offs, right? And I think I said at the beginning, it's like we have a very opinionated cloud architecture. But I think a lot of the gamble of doing this company such as it is that we're gambling on having made the right trade-offs. And I think that's kind of true for any technical decision, right? Like there are trade-offs that you have to make for your problem domain, and you can get way better performance under certain circumstances by making those trade-offs and not on others.
When I worked at Amazon, one of my favorite things was there was a emailing list called Ops Wins, and anyone could email this email list and anyone could subscribe to it. And it would describe something that they did on the operations side that was a win in whatever definition that was for a win. And I loved it because it was like, we tweaked this portion of a load balancer and it reduced latency for like 90% of customers. And I was like, that's amazing. Like there's someone who just went through, and it's a lot of it was just about like some one or two people diving deep for a month or two and saying, hey, I need to find this specific use case or this specific reason that this is happening in our logs. Let me block out a couple sprints and we're going to figure it out. And maybe we're going to get something out of it. Hopefully we get something out of it, but not always, right? Like it doesn't always come up. But I feel like a lot of companies, especially large companies, don't celebrate the operations side of things and how that impacts the business. And almost every one of these Ops Wins emails had a dollar amount attached to it, where it said like, hey, we reduced storage by switching on this feature that was a new thing that a service had, and now we saved $1 billion every year. And it's just like, whoa, like that was cool. Like someone just went in and just like, well, let me just test this. Let me make sure it can deploy. Okay, and we'll go through. And most of them were like roll-ups for like a PM did a thing, and it actually happened 6 months ago, but it was awesome to see. Every time I come through, I was like, I love the Ops Wins emails, and I wish more companies had that sort of stuff to really celebrates how architecture changes, and someone diving deep into a problem is like, oh, that is what we actually want to encourage people to do, to go figure out why that's happening, figure out who it impacts, and then figure out like what we could do to change it.
How is your product queried? Is it like a SQL query, or like how do you do queries with your?
We have I guess the closest analog is something like the Splunk query language or the Elastic or the Kibana query language, I guess is what they call it. It's not SQL. It is generally less powerful than SQL. It supports filtering, pipelining, and aggregation. So you can say like, oh, I want to look at all things that have this word in them. And then I pipe it through like a stats table to like group it by some quantity. And then I take that and like sort it by this other quantity, right? That's like 3 commands that you can pipe in sequence. It is not SQL. It is less powerful than SQL. You can't do stuff like joins with it in particular, I think is the biggest difference between something like this and SQL. And it is, once again, I think it's like a trade-off, right? It's like, people want something that's close to what they're used to. And a lot of people come here from Splunk or from ELK or from Datadog or similar products, and they want a query language that is familiar to them. So it is technically our own query language, but it's designed to look like Splunk as much as possible.
Okay.
There's like a whole rabbit hole of like, we wrote our own parser type stuff that I think someday would make a cool blog post. But
So do they have to learn that language to use your product, basically? Like, is
Mhm.
Okay.
Yeah. I mean, again, I think we try to design it like Splunk as much as possible. Yeah, at some level, you do have to learn some properties of the new language because the system has different properties. And like the query language is directly an interface to that.
Okay.
Cool. Well, Steven, thank you so much for coming on the show and talking to us all about Scanner and what you do and how it's architected. That was really cool.
Yeah, thank you. Thanks for having me.
Yeah, thank you for coming.
If people want to find you online, where should they reach out?
You can email me. I'm SWWU, that's my initials, at scanner.dev. You can also just go to the website, scanner.dev. It probably will explain the product much better than I did.
Cool. All right. Thank you so much.
This is a changelog news break. The Phylum research team writes, quote, like the island of discarded plastic twice the size of Texas, floating in the North Pacific Ocean, NPM has accrued an astonishing amount of spam packages over the past 6 months. Our 95% confidence interval for the estimate of T, that's TEA, the protocol spam, in new packages over the past 6 months jumped to between 68.66% and 74.67%, or somewhere between 613,000 and 667,000 packages. In other words, among all new packages published to NPM in the past 6 months, about 5 out of every 7 packages are T spam. End quote. I first covered the unintended consequence of the T protocol's crypto rewards back in February. That was episode 83. It appears the damage is even worse than previously discovered. What a mess.
That is one big pile.
You just heard one of our 5 top stories from Monday's Changelog News. Subscribe to the podcast to get all of the week's top stories and pop your email address in at changelog.com/news to also receive our free companion email with even more developer news worth your attention. Once again, that's changelog.com/news.
Thank you so much, Steven, for coming on the show today and talking to us all about the infrastructure and scaling for Scanner. Let's jump into the outro here for what used to be called How Things Break. And now this is kind of like a regular occurrence that things have been breaking. And so I think we just did one of these recently, but we wanted to talk about, because we talked about CrowdStrike recently. And we're actually going to lean into talking about some of the outages that Azure had in July. And I know this podcast is coming out in August, but we're looking back a little bit here. And first of all, I want to say, like, no shade to the people that run these services, people that are responsible for them. This is absolutely a complex system with unknown variables. And like, we understand that like things happen. We also want to like say that at least my opinion, like outages are generally like an organizational problem. This is not an individual, a service, or like a mishap. It's like, oh, who wrote that line of code at CrowdStrike? Like, it doesn't matter, right? Like the organizational processes and protections that were in place allowed it to happen. And that is a different problem than who wrote the line.
But be real. We are all engineers and engineer adjacentness here, and we all know that if you keep firing engineers and you keep saying that AI and all these automated things are going to do our jobs, eventually, like, we keep having these outages, we're all like, well, what do you think was happen.
The year of 2024 seems to have more and more problems. And I don't know if that is generally because, I mean, obviously, like a lot of people have been let go from jobs. And I just saw a stat today that it was like 30,000 people, developers in the gaming industry, were recently let go. Like Bungie had another set of layoffs recently. And it was like a third of all of the engineers in the gaming industry were let go at some, like in the last year. I'm like, that
I
is,
think the amount of institutional knowledge that tech has lost with the reshuffling, like even if you didn't fire, I feel like the ones that are still there, we all have survivor's guilt, and the people that got laid off have left. There's so many, like we just, it's not a good, the vibes are off. Okay, like we are out here. Like it feels like everybody's like riding the struggle bus. You talk to like your friends and everyone's at a different company and everyone is just, the morale is not, it's not great, you know? And
yeah.
I think that the amount of people that have lost their jobs, and like, I mean, there were people that were fired from these big companies that like they had so much experience. They had built so many of these services and had so much institutional knowledge. You cannot, like that one dude from Google who had like 16 years, wasn't the guy that did the patent for like search fired from Google? You know what I mean? Like you can't tell me that like you YOLO fired all these people and you thought nothing bad was going to happen. Like,
Yeah.
don't know.
At some point, that's like the business decision of we need to be profitable or we need to make money, and so these people are really expensive. Let's get rid of them. Is wild to me because
That is cool because the profitability depends on your services being reliable. Like, you know what I mean?
and a lot of these, I would say, centralized services, cloud environments, whatever you want to call them, the companies that have been letting people go, like you have to shed that load because like you are reducing your capacity to do things. And for some people, they say like, oh, AI is going to solve it for us. But in other cases, like we have to just shed the load. And so they're either deprecating services or they're deprecating customers, right? Like they're getting rid of something to make it easier to operate this stuff. And software doesn't operate itself. And so it's,
But it's just wild to me that they were so willing to make this investment into AI, which it's not saying that there isn't going to be something good that comes from AI, but it was such an investment at the loss of humans that have been doing the work and making it profitable for you, you know? And like, okay, you're building software, but so much work goes into maintaining it, into being able to fix the outages. And okay, you released it, and now how are customers going to use it, and how are we going to break it on accident? You know what I mean? So,
and the maintenance is why this podcast exists, right? Like I love talking about the 90% life cycle of software, right?
that's the hardest part of software. Like writing it is cool, but what happens when this edge case that you didn't think about comes back to bite you? Like, you know?
So talking about the Azure outage that happened on July 30th, 2024, they had a denial of service, a DDoS attack at Azure Front Door, which is like their CDN component, right? And so like they were having this DDoS. They don't say in the outage how large it was, but they say that there was a DDoS attack. And so
maybe we should give a little context. So a DDoS attack is a denial of service attack, which I'm sure most people know, which means your compute or your service is getting overwhelmed with a bunch of requests. Usually.
And those can happen all different ways, right? You can either have too many connections going in, which is called like a SYN flood, where everyone's like, hey, open me a connection for me. And then it just never closes. You could have just sending too much data, like network pipes are only so big. You can only send so much data over. And if everyone sends it to the same endpoint, like all of these reasons, like they don't go into details of what that DDoS was, but they say in the outage that like there was latency spikes from a DDoS. And so they had to mitigate that. And this is at the CDN level. Like this is all where traffic comes from, everything for all of their services.
Also, CDN is a content delivery network, which is usually when you're putting content all around the world. So you can make latency lower for people trying to access your more popular or more accessed content. So it lowers your latency.
Right. And that is a component of caching where you just say, we're just going to put more data close to someone. And you have all these little CDN point of presences pops all over the world. And hopefully someone's local network will route them in the right place. So you have ways of routing people to those CDN locations. But they were getting a DDoS. And it says in the, and I always recommend people go to like the source of these sort of outages. Like there's a bunch of roundups and people rewriting what Microsoft wrote, but I just go read the original one and we'll link it in the show notes. But they say the initial investigation suggests that an error in implementation of our defenses amplified the impact of the attack rather than mitigate it. So some automated system, whatever it was, created a change in this firewall ruling or this like load shedding setting that said, okay, well, like let's not accept all those requests, and whatever it was made the problem worse, and then basically brought down Azure for 10 hours.
Which a global outage for 10 hours is a long time.
Yes. And this is, CDN is again, this is Azure front door. So like everything is hitting this to get to the backend services. The backend services were all probably fine. Right? Like in many cases, all the backend services.
But you can't even access them because the CDN's down.
Right. If you can't get to the service, then it is effectively down. Even though all the backend services teams are like, my metrics say I'm good.
Which is wild because now your CDN, that what is supposed to lower your latency and make it more highly available, is causing your service to now not be available. Right.
There's always a load balancer or some single point that gets into the rest of the application, and many ways that single point can break. There's always a single point of failure notion in any infrastructure. You're like, I don't want a single point of failure. And it's like, well, like at some level, like your DNS might be that single point of failure, right? Or your IP address.
It's always DNS. It's always DNS.
It's always DNS.
But I think this also goes back to the point that you were making earlier during our interview, though. We can always architect things for what we think is going to happen, but sometimes something will surprise you because of something that is used in a way that's different than the way that you architect it, thinking of how it's going to go. Like you architect something with CDN, hoping it makes it highly available, and then you end up in a problem where it's stopping you from being available. So I think this actually adds greatly to your point that you made earlier.
Right. And like the Azure front door service, I guarantee you was architected for handling a DDoS, right? Like there is absolutely, like that is the front door service. Like you have to be able to mitigate something. So you either have something in front of it to load shed, but it does not necessarily always architect for, hey, we wanted to load shed. And also someone changed a setting that amplified the impact, and not say that it was the wrong setting, right? Like this setting probably was the right setting in a runbook somewhere that was the perfect thing to do in a different context.
Which is another reason why I think automating security things like this without like automation is always going to make things more efficient, but this is why you also need humans, right? Because you like when something happens and maybe like this works for 75% of the time, and then the one time it happens and it's not a good thing, you need a human to be like, oh crap, we we need to go fix this. Or
and automation is great until it's automating the wrong thing. Right?
Yeah,
like,
that's what I'm saying, but it can't make that decision and differentiate that sometimes. Like sometimes it can, but like I think that we will always need humans and people with the right context, because even if you had a human and they didn't have the right context, right? Like, but that's why the institutional knowledge is important. The people that built it and actually building things and not just having like other like things build it for you, like really being able to have the context you need to fix something, because you can't rely it like just solely off of like automation.
Well, and I told you the time that I took down Disney Animation for an afternoon, right?
No, but do tell.
Well, so like it was automation of like there was a Google Chrome patch that was being affected in the wild, and it was like, hey, we need to update this now across all devices. I'm like, great, we have automation in place to allow us to update Google Chrome everywhere really quick. No problem. I will run that command. It'll automate it. It'll get it going for us. What I failed to remember was that we also had Google Chrome installed on most of our servers for various reasons. And so when I did the update all of our Google Chrome installations everywhere, it did it thousands and thousands of times and made all of these outbound connections to Google, and Google blocked us. And Google said, hey, you can't make that many connections at a time. Like we will not allow that from any single IP address. And we were a G Suite customer, which also meant that Gmail was down and Google Docs were down and Calendar was down and all of these things. If you were on our ISP, on our outbound connections, if you're connected to the Wi-Fi or connected to any of the networks, like Google did not work for you. And that was an automation piece that I didn't know all the context. Like I forgot that happened, and I automated my way into taking down the building for a good like 3 or 4 hours during a production time, right? I was thinking it was like, which is funny. I think we were working on Ralph Breaks the Internet at the time, and I completely broke the internet for Google.
Oh no, you broke the internet.
I did, yeah. So for one day we renamed the movie to Justin Broke the Internet. But yeah, and so it was difficult, right? Because like that was an outage that happened that I caused through that automation, and
My kids are gonna think you're even cooler because now you're Justin that broke the internet.
but it was a really difficult situation that we had to work with networking teams to start dropping the connections out to Google on individual devices. We were scanning as many servers as we could. We were stopping the downloads that were going. Anyone that had a connection was going through a crawl, but then all these systems had like incremental backoffs, right? So they were all saying like, oh, well, I couldn't connect this time, so I'll try again in 5 minutes, which would then just block the internet even more. So I know how this works in an automated situation, and that really sucks that Azure was down for that long for this sort of thing. I also wanted to talk about the outage they had on July 18th, because that wasn't a global outage, but that was an outage in US Central, which took down, I think I counted it out, it was like 24 services that were backend services, right? So like the entire region was basically like, it was like SQL database was down. Virtual machines were down. This was all like fundamental things, including Office 365 and things like that, because there was a storage problem on the back end. And like, I always want these things to have more details than they have, but also I understand that like you can't share all of the details, because I've written plenty of these.
You also don't want to teach people how to do it later, you know?
Right. There is an internal postmortem, and then there's the public facing customers can see this postmortem, and that's just how it works. But that was another one that was over, I think it was 4 hours. Let's see, 9 o'clock to, this one goes all the way till 11 p.m. the next day. So, but this was also the day before CloudStrike happened, right? Like this was literally the night before CloudStrike, and they have another postmortem for CloudStrike affecting their servers as well. But this was specifically the storage happened before CloudStrike rolled out problems. So this was, Azure went down that evening, and then that night around whatever 2 a.m. or something, CloudStrike affected the rest of the world. So no one even noticed that all of these services were down for a little while because the rest of the world broke.
Yeah, it was already down. So they were like, nobody had access.
It's like, you know what? Azure does not matter if my local machine is blue screening.
Yeah.
But yeah, no, well, I'm going to have links to these in the show notes just because actually they don't have a permalink. I don't think they have a permalink to this specific outage. They just have the one page. So I'm gonna have to find out if I can put a link to both these in the show notes. But in both cases, it's just like these things are happening at larger scales as we start to centralize more and more stuff. And not saying centralization is always bad, but that architecture of centralization can have a much broader impact.
Interesting.
That's all you got.
I mean, I don't think it's centralization. I think we've made a lot of interesting business decisions, and now those things are coming home to roost, but we'll see.
Well, I mean, the business decision of moving to Azure, right? Like that is a business decision that has affected people.
No, I think it is all of things that are going on in tech in general. I think we are seeing a lot of the same things happening everywhere.
No, but I mean, you're tying, if you are a customer, you are tying your availability to the providers that you pick, and their decisions to re-architect their implementations or lay off engineers or move everyone to AI impacts your business, your ability to do things. And so these are partners, and you have to make sure that you pick the right partner. But again, their business incentives change too.
Yeah.
And at some point you have to be able to renegotiate or at least reevaluate your business decisions from before, and tying these things so tightly to one location and one provider is extremely dangerous, as they are businesses that are making money as well.
Yeah.
All right. Well, thank you so much again, everyone, for listening. And if you want to hear some people on the show, feel free to email us. It is shipit@changelog.com. And we will talk to you all again soon.
3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at Fly.io, to the mysterious Breakmaster Cylinder for these dope beats, and to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.